All right, so I just pasted in the problem at the top there. So just give it a read through and then we can get started.
Alrighty, sounds good. Okay. All right, so it seems like we are going to be adding 1 to an array of integers, and we're going to have to account for the edge cases where we might have the number like 9 or 99, in which case we'll have to make the array 1 digit larger. So I'll make sure to account for that in my program. So I think the way that I'm going to do this is I'm going to take the size of the array and then add 1 to the last digit. And then if there's a carry, I'm going to do the operations on all the other digits with the carry, as it has that ripple effect that goes through the number. Yep. And then, at the end, I'll add 1 to the size of the array to make the number 100, 1,000, or whatever that number might be.
Okay.
Alrighty, so I'm going to write out some pseudocode for this just to show what my approach will be. So I'm going to have a function called like +1.
Sure.
And I'm going to take the size. I'm going to say int n, for instance, is the array size. And then the way that I'm going to find the carry is, the carry has to be the tens digit of the number that's the result of adding 1. So I think I'll do a Boolean and say like bool carry will be, I'll need like an if statement here. So if the digit, so like array it would be n-1. This. So if the result of adding 1 is greater than 9, then our bool carry would be true.
Okay.
Because we have to do that. And if not, it would be false. And the reason I'm doing it as a Boolean is because yes, we have to carry. And then the second reason is that carry value will only ever be at most 1, since 9 plus 9 can only be at most 18. So that tens digit would only ever be a 1, like no bigger. So I think it makes sense to have that as a Boolean value. So yeah, that'll be our test for carrying. And then we're going to have to change the results that we get in that last position to be just the ones, like the ones value of that number, if it's above 10. I mean, if it's above 9. So
okay.
We'll take the result and mod it with 10. So then in that way, we'll get the ones digit. And then that'll be just the result at that space. Yeah, so then from there, we're going to basically do that same logic and do that on every position in the array, using that same like carry logic with the mod 10 to get the result. And then if we get to the point where we need to make the array larger, so say if we add 1 to 9 or 99, whatever, we'll have to make it like 1 space larger. So if that's the case, the way we'll know that is our carry will be true after we reach the end of the size of the array. So if our carry is still true after all of that, then we'll know that we reached the end of the array and we still have to carry, so we still have to add 1 more space. So if that's true, then since we're working with vectors here, well, when I implement it, it'll be vectors. We can just use a pushback. So I'm just going to say, like, let's say the array is digits. So digits at 0 will be 1.
Yep.
And just make a reminder that we're making this 100. And then we're going to use pushback because that's one of the methods in vectors. I'm going to say digits dot pushback. And by saying 0, it's going to make all the rest just 0. So that will take care of our edge case. And I think that that is all we will have to account for. yeah, so if it's good with you, I think we could probably get started on implementing this now.
Yeah.
Alrighty, so I'm going to say, so since we are not returning a value, we just make this a void value, I think. So void, well, no, we need to work with vectors. So I'm going to say vector int +1, and this is going to take in a vector of also type int. I'm just going to call it array just for the sake of clarity.
Okay.
So this array is going to be our number in digit form. So I need to get the size of the array. So I'm going to say int n, I'll just say int size equals array dot size, or size of this array. So we have our size, and then we need to start working. I'm just going to make a note here. So we have like our indexing is going to be 0, 1, 2, 3. So if we want this 3, it's going to be the position of size -1. So we're going to add 1 to this. Plus equals, why is it? Oh, I thought that was commented out for some reason. No, we're good. Okay, so +1. So this is where we're adding 1 to the last digit. And now we have to determine if we need to carry. So we're going to say bool carry. It's not at all how you spell that. Equals, we'll have an if statement. So if this is greater than 9, then our bool carry will be true. And then else, obviously, carry is false. And I might just declare this at the top so that we don't have any issues later.
Yeah.
So bool carry. Oops. Great. All right, so yeah, so if it's greater than 9, we do have to carry. If not, then we don't carry. So that's fine. And then we're going to have to adjust the number that's at this last position, because if it was like 79 and we need to get it to 80, right now it's at like 7, 1, 10 because we added 1 to 9. So we have to adjust what this last position says. So to get that ones digit, we're going to say array at the spot we're working with is what it was, and then mod 10. So it's that same idea of just modding 10 to get the ones digit, whatever it might be.
Right.
And if this is less than 10, then that's fine because it'll just be the identity of whatever that number is since it's less than 10. So that'll work out perfectly. All right, so that's our first operation on the array. And then from here, we have to do this cascading effect of whatever the carry might be. If it has to go through the whole array and carry, we need to take care of all of those numbers. So I'm going to set up a for loop and say int I equals I minus 2. And I'm saying I minus, well, not I actually, size. Oh, I'll say this is size, not weird to track of my stuff. And I'm saying -2 because we want to move over like 1 space. So
why start the for loop here? Why wouldn't you just do it from the start?
I think that I set it up this way because, well, I guess we could actually. I was thinking because I don't want to include that adding 1 in the for loop, but actually, yeah, I could implement this just in the beginning. So
Because I assume the logic for every step is going to be similar. Because if you have a number, like let's say we have like 199, then you'd have to do the carry check here and then the carry check again, and then you'd update that.
Yeah, true. Okay, so yeah, I will then do this for loop in the beginning. So size minus 1. Size is, we want to be, well, not size, I. I has to be greater than 0 because when we get to that first position, we're going to have to do something else. That would be our edge case. So I'm going to index that to be 0. And then since we're going down the numbers, we're going to subtract from I. So
how come you don't want to go to 0 again?
Because when we get to the 0 position, we, like, if it's 1, we want it to go down to 1, and then I will be incremented to 0 again. And then if it's at that 0 position, then we want to add a space in the array.
Oh, okay, so for the 999 case?
Yeah, for that case, right, yeah.
But what about this one here? Wouldn't we want to update the 0 index here? For 37? Or now 38?
Wait, yeah, actually, okay. So then I is less than or equal, I mean greater than or
yeah.
equal to. Okay. Yeah, that makes sense. Okay, so that's good. This is the end of our for loop. I'll need this one. That's all. Not deleted stuff that I needed, but not a problem. I can just fix it. Yeah, so just to fill in what I had before that I accidentally deleted, my mistake. We did our carry. So then this is where I was. Oh wait, no, that was fine. Yeah, so I should keep those to keep track. This fixes the that last position that we had. So this updates our number that we're dealing with. And we want this to be at I. So now that we've created this new for loop, we're working with right here. So we have our, all right, so we have our increment here. We have our carrying, and now we're updating the position that we're working with. So that should work. Yeah, and we just don't want this to go any lower than 0. So like how you said, we're going to hit 0, but not go obviously any less than that. So yeah, so now we're going to account for our edge case, which is this 99 to 1000 case. So I'm going to say if at the end of all this, so this is going to run through, and if this carry is still a true after all this is done, then we're going to have to push back. So if carry is true, then this is going to happen. So we're going to say, since we're going to convert it to 1000 or 100, whatever, we're going to say that array at index 0 is 1, and then array.push back is going to be all of zeros, like this. Yeah, so that should return correct number for that edge case. And this is doesn't correct size.
It's array.size.
Okay.
And then it's like a function, a method call. So you have the, yeah. Yep.
Okay, so yeah, I think that this would be the way I would give my solution for the problem then.
Okay.
Yeah.
So
This is, yeah.
if we walk through 38, I think there's one little piece missing. I'm just trying to see where exactly it is. But so you increment the ones digit here, right?
Oh, we need to
So
increment.
then, what do you say?
I was thinking that we might have to increment it again in the for loop, but then I backtracked because we actually don't, since we only incremented that one time. So never mind, sorry.
Okay. So this will be 0 now, right?
Yeah.
And then this on the second iteration is going to be 190 with the carry true. Then the carry will go to false here because this is not greater than 9. And then we say that array at index 1 is this mod 10, which would still be 9.
Okay.
So I think there has to be another increment around in here somewhere in this loop. I think.
Okay, I see what you mean. Okay. So we're testing if it's greater than 9, and if that's true, then we carry.
Because even just for an example, like, oh no, okay, I guess that would, yeah, I think this is going to be a weird one. I could be wrong, and this could be completely correct. I'm just missing where this number can be set to 0, basically.
True.
So then we can set this over to 2. But I just miss where that happens. If you can show me where that is, I might be me just missing it.
Yeah, so let's see. So when we did this addition of 1, so I think we need to, let's think. Maybe I should make my carry, instead of a Boolean, maybe make it an integer, so then you can do that addition of 1. So say if you have a carry, then add the carry. So you would be adding 1. And
right.
then, so I think I should backtrack, and instead of making all these carries Booleans, I think I should make them integers. So
yeah, you can just make it a 1 or a 0 to do the same thing.
Yeah, I think that would be more useful since we're working with all these math operations. So
yeah.
I think another way I could say, all right, so I'm going to say int carry, and then the way that I could get this to be an integer operation, I could just do array of, oh, also this can be an I. So array at I could just divide it by 10.
Yep.
Because if it is above, so basically anything below 0 would just be a 0. I mean, below 10 would be a 0 because it's integers, whatever. Okay. Yeah. Yep. So that should work. And then I actually don't even need this else case, I think. Yeah, because we'll just test for that one thing. If it's true, then do that. Or actually, no, we'll have to initialize carry to be. Well, maybe I could actually take this whole thing out and just have carry be 1 from the start, because that's almost the same.
Yeah, that's a good idea.
Thing. Okay. So carry equals 1. That's like adding the 1.
Yep.
And so if we add 1, so carries 1. So yeah, I don't need this either because that's for the Boolean condition. All right, so yeah. All right, so we added 1, carry is this, array gets changed.
Where do you do the adding 1?
Adding 1, oh, right. I'll do it in here.
Okay.
Equals, Oh yeah, this makes more sense. Okay, because then you'll either be adding a carry or not. So then we'll say
Yep.
Carry. All right. So yeah, and then we'll change carry. So then that way it'll be different every single time it has to be. And yeah, and then we'll adjust our last one by 10 with the modulus. And then this is, oh, we don't want this anymore. So if at the end of that, if it's still 1, then do this. Okay.
Okay.
I think this would work then, because if we have this case for this 1900, I mean, whatever, not 199, yeah. So if we add 1 to that, then we're saying carry is 1, and then array of I, which would be this 9, we add 1 to that, and then the carry is divided by 10. So then, yeah, so then that'd be 10 divided by 1 would be 1. So then yes, carry, good. Modded by 10, so then 10 mod 10 is 0, good. That gives us this 0. And now we go back and we do have a carry, so we would be adding to, oh right, so then we'd be adding 1 to this 9, which would make sense. Then go through it again, we have a 10. Divide by 10 for the carry gives you a 1 again, and this would be a 0, and then we go through it again, it'll be a 2. So I think this takes care of that case then. Yeah. So,
yeah, I think this is good. I feel like there might be a conditionals check somewhere, but I think this is good. I think this will work.
Okay.
Yeah, I mean, I feel like there might be one little thing here with checking for 9, but I think overall, like, I get the logic, so it makes, if we could run it, we could definitely debug it really quickly. So I'm not gonna, take any points off for that. So
okay.
yeah, well, good job. You have any questions?
No, I don't think any questions. Yeah, do you think there's a benefit to iterative versus recursive for this one, or do you think like iterative is all right for this one?
Yeah, I mean, you could definitely do it. There's probably a way to do it recursively, but the thing is, we're basically, we probably have to pass that by reference and then just actually edit our array here a lot. So I think the iterative is much cleaner, makes a lot more sense. Because then we'd have to have like a helper function where this takes in like, our current index or something like that, just so we can actually follow it. So I think the iterative makes a lot of sense here. So
Okay.
plus, it's better we can minimize calls because we only really are doing it like 3 times. So this is probably pretty quick. So yeah, well, good job.
Thank you very much.